Hi! Let me show you how to go from your turbomachinery geometry to a CFD mesh using AutoGrid5. This is AutoGrid5, an amazing tool where you can create in minutes meshes for your turbomachinery CFD projects. Let's see it in action. I will start a new project. When you start a new project, you have two options. You can import your own CAD when you start a new project from scratch, or if your geometry has already been prepared in the native format, you can simply load the Geom Turbo file and the geometry will appear in the interface in a matter of seconds. Here we can take a quick look to the 3D view. There it is, our 3D blade. Let's start the Raw Mesh Setup Assistant. The first thing that the Raw Mesh Setup Assistant does is to check your geometry. If everything is okay with the geometry, you can move on to the next step, where you will have to select one of the different configurations depending on your blade road type. As you can see, we can do with AutoGrid different turbomachinery configurations ranging from axial to radial or mixed flow configurations, and well, the library of templates is wide. In this case, we have an axial turbine. The periodicity number is 46, and it's a stator. It's a nozzle vane. In the next step, you can define gaps, tip gaps, or fillets for your blade. In this case, it's a vane, so I'm just going to define fillets both at hub and shroud. And as you can see, changing the definition of the fillet is just a matter of changing one parameter. Next, you can define the global wall cell width and the span-wise grid points number. Notice that AutoGrid is continuously checking grid quality, like in this case the expansion ratio. In the final step of the Raw Mesh Setup Assistant, you have to modify a few parameters for the blade-to-blade control. Let's preview the blade-to-blade mesh as is. As you can see now, we already have an amazing grid. The periodic phases are perfectly matching, and even for this high stagger blade, we have almost perfect skewness in the periodic zone, in the throat zone of the nozzle vane. Our viscous layers insertion has been taken care of, and if we want to reduce the grid density, we just need to go down with the sliders here, click preview B2B to update, and there we have a new mesh with lower grid density and still amazing grid quality statistics. So let's take a quick look to the skewness distribution. As you can see, this color map helps you to easily identify potential problematic regions of your mesh, but in this case we already have a minimum skewness of 43 degrees, which is very good. And you can also check expansion ratio distribution. Once you're done checking grid quality, well, you can just finish the Raw Mesh Setup Assistant, and you will be naturally prompted to generate a 3D mesh. So I will click yes here, and we'll wait a few moments to see what we get in the final 3D mesh. Okay, the final 3D mesh is complete. Let's take a look to the grid quality report. Here you get a quick summary of the grid quality statistics and the CPU time to generate the 3D mesh. And if you're happy with the results of the report, well, you can proceed to inspect the 3D mesh. Let's take a look to the 3D mesh. So AutoGrid can show very easily the grid, in this case rendered at the hub and the blade. And as you can see here, we have these fillets that we have imposed with the few settings of the Raw Mesh Setup Assistant. And now let me also show you the rest of the grid. So here we can toggle on the block edges, maybe we can apply some shading and visualize the grid lines. And I will show you how nice it looks around the fillet of the blade, and how this multi-block topology is perfectly connected. If we toggle on periodicity, we can confirm the matching connectivity across the periodic boundaries of this high stagger blade, and as you can see, the orthogonality is really good. So that's AutoGrid5. As you can see, with the Raw Mesh Setup Assistant, it's really easy to generate your CFD mesh for turbomachinery applications. Now let me quickly show you a new example. In this case it's a centrifugal compressor, and we're going to look at the mesh that is the result of using the Raw Mesh Setup Assistant with AutoGrid5. So we have a stage. It's the row 1 is the impeller with a splitter blade, and row 2 is the diffuser of this centrifugal compressor. So let's inspect the blade-to-blade view, and as you can see here, AutoGrid Raw Mesh Setup Assistant has created a very nice grid around the main blade, and also with fully matching connectivity for the mesh around the splitter blade. Now let's take a quick peek to the trailing edge, so we can see how AutoGrid5 treats blunt edges in blades, and the result is also impressive. Let's review a few AutoGrid5 facts. AutoGrid5 is a tool that focuses on turbomachinery CFD meshing. It creates multi-block and multi-grid structured CFD grids. It features the unique Raw Mesh Setup Assistant. With the Raw Mesh Setup Assistant, the meshing process is highly automated, requiring minimum user input. The optimized topologies will always result in high-quality grids. If you'd like to learn more, give us a call or visit numeka.com.